Hey everybody, it's week 6, which means we're closing in on halfway through the semester. So far, I'd have to say I'm really pretty happy with the way things are going. You all seem to be picking up the concepts pretty well, getting things turned in and doing pretty well on the quizzes and assignments. Um, One piece of advice, if I could, to pass on is if you can, if at all possible, you might want to think about trying to submit the first attempt at a quiz and assignment earlier in the week if you can. I try to check and get the grading done as they come in during the week, at least in the evenings. It's a little harder to keep up, on the weekends. Things are going on, and weekend submissions tend to get to on Mondays or Sunday nights. But if you can get something in earlier in the week, I'll try to grade that as soon as possible, and then you can check out how you did on the first pass through, and if you need to or if you want to, take that ability to submit a second time and retake the quiz and redo the assignment and bump things up based on how you did the first time. Last week we talked about file permissions. I just want to go over that a little bit, and just kind of let you know that if something wasn't clear, or if you still have questions about that, definitely ask those questions in the discussion board. Read through the material again. File permissions are one of those things that it's just one of the concepts you really really want to know pretty well. You can run into situations where strange things are happening. Something isn't working quite right, and a lot of times that'll come down to file permissions. Something that you think should be able to write to a file actually isn't, and that can cause what seems like strange errors at first. But if you're really familiar with the way the file permissions work and all of that, then a lot of times that can help you track down issues. So definitely get a handle on those. That you'll find probably be pretty important for working on systems like this. This week we're gonna talk a little bit more about the shell and some command line stuff. Some of the reading anyway is going to be review, and some of what I'll talk about will be review. And then we're going to talk about editors on a Linux system, in particular the VI or Vim editor. VI is the old school, the original editor, and then there are several clones of that, several improvements on it, and kind of the standard now is Vim. That's what you'll generally find installed on most of your Linux systems. And while it's not the only editor, and it's not the only one you have the choice to use, and there are some out there that you may like better or maybe easier to get started with, VI or Vim is pretty much the only editor that for sure will be installed on any Linux system you get on. So it's a pretty important editor to get to know, even if it's not your favorite. So we'll talk about that some. There's a quiz this week, but I don't have an assignment this week because we're going to be talking about the editor and the Vim and all the control characters and stuff, and the way it works with the screen isn't really conducive to using the script command to record your session. Plus, I have a couple of chapters of reading for you this week, so I'm not giving you an assignment to give you a little more time to get through those 2 chapters and really try to understand that material. So let's get started with the material for the week. So the first concept I'm going to talk about this week is related to the shell and running commands. And that's the command line redirection, specifically I/O redirection. So when you run a command from a shell on a Linux or Unix system, every command has 3 I/O input-output streams. There's your standard input, known as standard in, and abbreviated as you see, STDIN. It's standard in, standard output or standard out, and standard error, which is called standard error. By default, standard in is the user input via the keyboard, and standard out and standard error are sent to the window where the command was executed. So keyboard and screen are the standards, the usual standard input and standard output. But those can be redirected, as we'll look at. So you can get standard input from another command in a pipeline. You can redirect it from a file, and then you can do the same for standard output and standard error. You can redirect those to a file. You could redirect them to different files. You can send them to a pipeline that would go to another command and become the standard input of the second command. And each of those standard input, standard output, standard error, those I/O streams all have a number associated with them. So standard input is 0. As I said, that's the keyboard input by default. And you can redirect that with the left angle bracket. So that redirects from a file into your standard input for another program or for whatever you're running. And that can be read by programs to get input to the process. So if you have data in a file, you can use the left angle bracket to redirect the data in the file to the standard input of the process you're going to run. And then standard output, or stream 1, is the normal output from the command that you run. So you run any command echo or ls or any of the commands you run from the command line. The normal output that they show you is their standard out. And the default target for that is the console or terminal or window where the command was executed. Kind of the shorthand for that would be the screen. And so whatever your screen is, whatever you're looking at when you run the command, that's what your default standard output's going to be. And standard output can be redirected to a file with the right angle bracket, or if you double that up and do 2 right angle brackets, that appends to a file. So the single right angle bracket will write the output to a file. If that file already exists, it'll overwrite that file and append the current output to it as the only contents of that file. If the file already exists and you use the 2 brackets, it'll append the data to that file. And then you can also, instead of redirecting to a file, you can use the pipe character and set up a pipeline so the output of one command becomes the input to the second command. And the third stream, or I/O stream number 2, is standard error, and that's the error output from the command. So the normal output goes to the standard out stream, and the error output goes to the standard error stream. And like standard out, the standard error is normally sent to the console, terminal window. It's sent to your screen. So when you're running command, if you get normal output and error output, you'll see them both together on your screen because they're both targeted to the same place by default. And like standard output, you can redirect standard error to a file. In this case, you would use the number of the streams, so 2 and then the right angle bracket to redirect to a new file or to overwrite an existing file, or 2 and 2 right angle brackets to append the standard error to an existing file. So here's kind of the master list of the different input and output file redirects that you can do. So left angle bracket and then the name of a file redirects to the standard input of your command from a file. Right angle bracket and then the path to a file redirects standard output to a file. And then double right angle brackets redirects standard out to a file but appends to the file instead of overwriting it. And the same for standard error, so 2 angle bracket and the path, 2 double angle bracket and the path to a file redirects standard error to a file or appends standard error to a file. And then there's a kind of a shorthand. If you use the ampersand in an right angle bracket, or the ampersand in 2 right angle brackets and give it a path to a file, and that redirects both standard output and standard error to a file. So you can redirect both of them and write a new file, or overwrite a file, or redirect both of them and append to a file. And then the other redirection method is the pipe, and instead of directing to a file, the pipe sets up a pipeline. you can imagine one command and then a pipe connecting to the second command. So the standard output of the first command becomes the standard input of the second command. And a quick example of that is, you could use the ls command to list all of the files in a directory, and if that file's got if the directory's got a lot of files into it, that'll scroll off the screen. So you can do things like you could pipe it to the head command and just get the first 10 by default, but you could use head to get the first few lines from the output. You could pipe it to tail to get just the end of the output. You could pipe it to less to page through the output one screen at a time. And you can use multiple pipes, so you can take the first command, pipe it to the input of the second command, and then that command can do some work on it, and then you can pipe it to a third command, and etc. You can just keep going with that until you get to have all of the commands working on the output that you want to work on it. And then one handy thing to know when you're redirecting output is, say you want to run a command and it prints out a lot of output, and you don't want to see just the normal output because it's just simple log messaging, something like that, and you know that if it's working correctly, you're going to see a bunch of output, but you want to see the errors. So if it has any errors, you want to see those on your screen, but you don't necessarily want to see screenfuls of normal output. Unix and Linux have a special device called devnull, the null device. It's also called the bit bucket. And when you use that as an output target, anything that you send to it is discarded. It just goes into the ether and disappears. So you could use that and use the right angle bracket, redirect the standard output of your command to the file devnull, and all of that output will be discarded. It won't show up on your screen. And if you just discard the standard output, anything that goes to standard error will show up on your screen. And you can also use that file as an input source, and as an input source, it provides a stream of null values. And one of the handy things with that is if you've got a big file, you've got say a large log file, and it keeps growing, and you don't necessarily need to save the output, but it's taking up too much space. You can redirect the dev null file into the log file, and basically keep the file, keep it in place. Don't change the inode or anything, but just zero it out and make it an empty file again, and then the logging will fill it back up. So let's look at how some of those I/O redirects work. A couple weeks ago, for one of the assignments, I had you use the sort command to sort the list of the months of the year in a months.txt file that I provided for you. So I've got that file here. So in the assignment, basically what we did was the normal way to do that would be you would use the cat command, months.txt, and use the pipe to pipe the output of the cat command to the input of the sort command. But you could also just redirect that from a file. So you could run the sort command and then use the left angle bracket and use the months.txt command as the input, and use the file months.txt as the standard input for the sort command. And you can see it basically does the same thing. Now if you wanted to take that sorted output and save it to a file in sorted order, so you can still use that as the input, and then you can use the right angle bracket and redirect that to a file, let's say months sorted.txt. So that's going to redirect the standard input and then redirect the standard output back to a file. So you see I get no output to the screen because I'm redirecting my standard output. But now if I look at the months sorted file, you can see I've got the list of the months in alphabetical order. And of course the first example and what you did before was using the pipeline to redirect the output from one command to the input of another. We'll do that again quick just to just to reiterate, months.text, and then we'll use a pipe to send the output of that to the input of the sort command. So in the example in the slide, there was the ls command being piped to head. So if I wanted to do ls-al on the /etc directory, see that's a lot of files in there. So if I just wanted to see the beginning of that, I could do ls-al etc and then pipe that to head. And the head command shows the first few lines of the file or whatever is coming in on its standard input. Or I could switch that to the tail command, which does just the opposite. It shows the last few lines of whatever is its standard input. Or if I wanted to see all of them, but I didn't want to have to scroll back through them, I could pipe that to the less command and scroll through that. And less by default doesn't necessarily like the control character, so I'm going to change my option for less. So now you can see that it will play nice with the control characters, the escape characters in there that make the output look in color. So then I can use the spacebar to page through that one screen at a time. So I mentioned much earlier in the semester about modern shells and how modern shells all have job control features. We mentioned that but didn't really talk about it much then. So I'll go over that a bit now, and what job control means and what it does is that it allows you to start a process, put it in the background or suspend it, and then bring it from the background back into the foreground, to kill it when it's in the background without having to bring it forward. All kinds of handy things that you can do with the commands in the shell. So when you're running a command, and it's it's a command that's going to run for a while or something that's going to stay running until you want it to stop, if you just run the command, it's going to stay in the foreground. Its output's going to go to your screen, just as you'd expect. But if you want to run the command and then go do something else, you can run it and suspend it and then put it in the background, or you can just run it directly so that it runs in the background. So if you're running a command and you want to put it in the background, you'd use the suspend key, and by default that's going to be Control-Z. And then once it's suspended, you can use the BG command to continue that process running in the background. And then you can use the FG command to bring the backgrounded job back to the foreground and reattach it to your screen so that it's standard output and standard error going to your screen, and it has the standard input from the keyboard again. When you run a job, the shell assigns each job. Well, the operating system assigns every running process a process identifier, or a process identification, also called the PID or the PID. And when you put a process in the background, the shell will assign that process in the background a job number, and that's usually a pretty low number. It usually starts with 1. And then if you put more in the background, it increments. And it assigns that job number to the processes that are running in the background, and that allows you to quickly access them and bring them back to the foreground, or that sort of thing, or kill it in the background. So when you're running a process, you run a command from the command line, and you don't put it in the, you don't suspend it or put it in the background. It still has the standard input from the keyboard, standard output to your screen. And you can use the interrupt key, which is by default usually the Control-C key combination, and that will send the abort signal to the foreground process and make it quit. Basically, that's the typical way you stop a command from running or quit a command from the command line when you're running it in the shell. However, if the command is running in the background, and you don't bring it forward, it no longer has the standard input from the keyboard. So if you want to kill a process that's running in the background, you'd use the command kill. And what kill actually does, when you dig into it, is it sends a variety of signals to the process. All processes on a Unix and Linux system listen for and take signals, and those different signals tell the processes to do different things. The three major signals that you're probably going to send to a command with the kill command are the default signal that kill sends is termination, or sigterm, and that tells the process, hey, you've got the termination signal. Stop what you're doing. Shut down. Shut down nicely. So whatever the process does when it catches that signal to save files or to close out its sockets or anything it's doing, it'll do that and then quit nicely. If a process is not behaving, it's not obeying the termination signal, sigterm, you can use kill to send it the sigquit signal, or sig. I believe it's sigquit or sigkill, depending on. It's also kill -9 is its signal number, and that tells the process that it is aborting. It is quitting right now. No saving. That's the real kill right there. That's the forcing it to quit. And then there's also a signal called HUP, HUP, and a lot of processes listen for the HUP signal, which you can use the kill command to send. And typically the HUP signal will tell the process to restart itself, or a lot of processes will use the HUP signal as the indicator that it should like reload its configuration files. So you could a process that behaves that way, you can send it the HUP signal with kill, and instead of having to quit it and restart it to load a new configuration or a changed configuration, you can just send it that signal. It'll reread its configuration file and start running with the new config without ever having to quit and restart. So let's look a little bit at how some of the job control options work. I have a tiny little shell script here called looper. We'll take a look at that. And all it does is it uses the shell true command, which is always true, and it does just a little while loop. So while true, it'll echo the phrase still true. It'll sleep for 5 minutes, and then it'll do it again until I tell it to stop. So you can see that in action here. So it echoes still true, it waits 5 seconds, echoes still true, and it'll just keep doing that until I tell it to stop. Since it's running in the foreground here and it still has standard input from my keyboard, I can use Control-C, and that will quit the command so it's no longer running. So now if I want to run that in the background, this wasn't really mentioned on the slide, but one easy way, if you want to start a command and have it immediately go into the background, you can run the command and then follow that with an ampersand character, and that tells the shell to run this command and put it in the background. So you can see that the command starts and goes immediately to the background, and the shell is telling me that it is job number 1, and the PID process ID is 7345. So it's still connected to my standard output to the screen, but I can hit the enter key and get back to a prompt, and it'll keep running and outputting to the screen, but I can still go back to a prompt. I can do a PS grep 7345, and you can see that that is the looper command that I just ran. But now if I hit Control-C, nothing happens because it's not running in the foreground. So I can use the FG command and then %1 to tell it to bring forward job number 1. So now it tells me that job number 1, the looper.sh job, is back in the foreground. Now if I hit enter, I don't get back to a prompt because that job is in the foreground, and I can use Control-C to quit the job. So if I run that PS command again, I get no output telling me that the looper command is running, because it's no longer running. I have quit it using the interrupt character. Now if I wanted to run in the background and I don't want it to send me output. Well, first let's look at, I'll run the command again. I won't put it in the background. So it'll run, it's in the foreground. Now if I want to put it in the background while it's in the foreground like this, I can use the suspend key, the Control Z. So you can see the shell tells me that the process is suspended. I'm not going to see output to my standard output because the command is actually suspended. It's effectively paused. And since that is the command I just ran, I can use the BG command to send it to the background. You can see that the shell tags that as job number 1, and it immediately starts running again in the background. It still sends the output to standard output to my screen, but again I can hit the enter command and get back to a prompt and continue working, although it'll periodically interrupt me with that output. So I can use FG%1 to bring it back to the foreground, and again use Control C once it's in the foreground to quit. Now if I want to do that, I want to run it in the background, but I don't want it to interrupt me, to print to my screen. What I can actually do is use one of those shell redirects. So I can run the looper command and then use the right angle bracket to direct it to a file, and we'll call that looper.out. So you can see it's running, it's in the foreground, but none of the output is coming to standard out. It's all going into that file. I have another terminal window open here. So we can do tail -f looper.out, and you'll see there's where the output is going. So now if I want that to continue running, I can use the Control Z to suspend it, and then BG to put it in the background. So now it's running in the background. I'm not gonna, my session isn't hanging. Because that's running with no output, I've got my shell prompt back. But if I go back to the other window, you can see it's still sending the output to looper.out. Now it's running in the background. I don't want to bring it to the foreground. I just want it to stop running. That's where the kill command comes in. And kill will operate on the job numbers as well. So I can do kill %1. And you can see that the shell reports that job number 1 is terminated. And then the command that had been running, the looper command, with the output redirected to looper.out. So I've made a copy of my looper.sh little shell script, called it looper2.sh, and that one it does exactly the same thing, but it echoes also still true. So if I want to run both of those at the same time and can use job control with them, I can start looper.sh, and I'll redirect that one to looper.out, so I don't see the output on my screen, but it'll be going to the file. And now that's running in the foreground, so I'll use the suspend to send that to suspend the command, and use BG to send it to the background. So you can see that one's running in the background. Now I'll run looper2 and redirect that one to looper2.out. So now that's running in the foreground. I'll suspend it, BG to send it to the background. So now that is command 2, or job 2, running. Now I can use the jobs command to list the jobs that I have running. See, I've got looper and looper2 running. Now if I want to bring one of those back to the foreground, I've got 2 of them running right now, so I can use that job number. So I could say foreground %1, and that brings the looper command back to the front. I'll suspend that and background it again, and I can do foreground %2, and now the looper2 command is running in the foreground. Suspend that and put it back in the background. Now I can run jobs and see that they're both still there, still running. So now I'm going to make them stop. I'll do kill %1 and kill %2. As you can pass multiple arguments to the kill command like that, so now it's killed both of those processes. So that's basic job control. There's much more information in the reading. Be sure you go through that. try out the commands that it's showing you there. Play around with those. Make sure you take advantage of the VM you have in the shell and read through the chapter and get the concepts down. So we'll move on to talk about editors because starting very shortly, within the next week or so, certainly uh, by week 8, halfway through the semester, we're going to be moving into doing shell scripting and some automation and taking some of what you know and turning that into scripts that you can use on the system. And of course, to write a script, you're going to need to use an editor. So there are many, many editors available for Unix and Linux. There are, of course, if you installed a desktop machine with the graphical interface, there are GUI editors that you can use. But from the command line, there are also many choices of editors. On a typical default install of most Linux systems, the editors you're going to get by default are ed, vim, which is also, as we'll see, the X editor, and not X as in X Windows, but X as in EX, which is started out as the extended version of the ed editor, which is a single line editor. And then there's the nano editor, typically installed by default. Those three you'll generally find on a default install, although in some cases if you install like a minimal system, you'll find that you don't have all three of those. And you'll probably just have VI or Vim. Like I said, there's a lot of other editors available. There are several other different versions of editors that are clones of VI. And there are other different kinds of editors that have pseudo-graphical interfaces, menu interfaces, that sort of thing that run from a command line. And the other major editor for Unix and Linux is called Emacs, and that's those two editors go back a long time with Unix and Linux systems, and those are the computer holy wars of their day. They're the Mac and PC of the Unix world when it started out. You have people who like Emacs and hate Vim or VI. You have people who love VI and hate Emacs. They're both very powerful editors. They both have lots of features and somewhat of a steep learning curve, but they're the two major most powerful text editors on your Unix and Linux systems. However, as I said, Emacs is typically not installed by default. That's something you'd have to add to your system. Whereas VI, or on most modern systems, that's VI defaults to being the Vim editor, which is VI improved. But on pretty much every Linux system, when you get on and you run VI, you're actually running the Vim command. And VI is the only editor that for sure will be on a Linux or Unix system when you get on it. That's the editor that's installed by default. If you don't install anything else, any other editors, do a minimal system install, you're sure to have the VI editor. So we're going to be talking about that because that is a pretty important editor to know. It's also kind of unique among text editors, systems that you may be used to, in that VI is a moded editor. And what I mean by that is that it has different modes that it runs in. So you start the editor, and it can run in insert mode. It's called insert mode, that's what you would typically think of as an editor mode. You start up any basic text editor. If you're on a MacBook and you start TextEdit, or if you're on a Windows machine, you start Notepad. Those are basic text editors. You start them up and you can immediately start typing. And if you want to make changes, you have the menus. You can set options and do search and replace and things like that with the menus. With VI, there really aren't menus. It has two different modes. It has a insert mode, which you can do your text input and all of that, and it has a command mode, which is where you can set options for your environment. You can run search and replace. You can move the cursor around. You can find text. You can You can do all kinds of fun things in command mode. It's one of the really cool things about Vim, but it's also one of the things that catches people off guard and is is can be kind of hard to wrap your mind around at first. But it's a good concept to learn, and personally, I'm a fan of VI and Vim. I think that the command mode, in a lot of ways, if you're just editing text, makes makes a lot of the operations really easy. You can do fairly complex things pretty quickly with VI's command mode. So I mentioned the X editor. So VI was originally the visual editing mode of the X editor. So kind of the original Unix editing, text editor was called Ed, which is short for edit, and it was what's called a line editor. So it would load up the file, but you'd only see one line at a time, and you could edit one line at a time, which is not the most convenient way to edit a file. And Ed was kind of superseded by X, which is Ed extended. It was still a line editor, but it added some more commands and some more powerful options. But people still wanted to be able to see the file they were editing more than one line at a time. So a visual mode was added to X, and you would run X, and if you wanted to run it in visual mode, which then took over the screen and showed you a screen full of text at a time, and you could edit it that way. The shortcut, the command to start the visual mode once you had X running was VI for visual, and then that proved to be so popular, people never really ran X in line mode. They would start it up and immediately type VI to go into visual mode, and so that just kind of became the command itself. So VI became a command. You could run it to command line and immediately jump to visual mode. So if you look on your systems, if you have VI installed, you'll find you also have X installed, and typically that'll just be a link to VI. And what that'll do is it'll start, it's the same binary, the same program, but it'll start it in X mode or in line editing mode instead of visual mode. I mentioned there are lots of different clones of VI. The four biggest, most used ones are called Elvis. There's NVI, Vile, and Vim. And the one you're going to see most often, the one that is the kind of de facto standard, the default version for VI, especially on Linux systems, is Vim. So that's the one we'll talk about. That's the one that you're probably going to run into anywhere you're going to use VI on Linux. So I said that VI has modes of operation. It has a command mode and an input mode. If you're in command mode and you press either I or the A key, that will change you to input mode. I is short for input or insert, and that puts your cursor puts you in input mode before where your cursor position was. If you use A instead, that's append. That's input after where your cursor was. So if your cursor's on the last letter of a word and you hit I and you start typing, you'll be inserting text into the middle of that word before the last letter of the word, because that's insert before the cursor. If you hit A for append and you start typing, your text will start after the last character of the word. You'll be appending to that word. And when you're in input mode and you want to go back to command mode, you would just hit the escape key on your keyboard, and that'll return you to command mode, and then you can do your search and replace commands. You can run any of the other VI commands that work in command mode. So the reading, the chapter on editors, and specifically the chapter on VI in the reading, has a lot of good detail, a lot of good introduction to the editor, and you're going to want to, hopefully you have time to do this, and you'll have to do this. And what I would recommend is have a terminal window open, and have the VI editor started or Vim editor started, and go along with the book and try some of the stuff out that it's showing you there, and get familiar with the commands and the editing. I'm going to demo a little bit of that here so you can kind of see how things work before getting into that. So to start VI or Vim, and typically, when it's installed on a Linux system, it'll be linked so that either command will work. So I can type VI, and it'll start. And you can see when I type VI, it actually starts Vim. Or I can type Vim, and it starts the same command or the same editor. And this, it's kind of the about screen. And when you're in VI or Vim, and you see along the left side of the screen there all of those tilde characters, that indicates that there's actually no lines there. So I have my cursor at the top of the screen, and that's really the only line that's available there. The tilde characters indicate that there are no lines there, so I can't scroll down, I can't do anything because there are no lines in the file. So if I hit I to go into input mode or insert mode, you can see that shows up at the bottom of the screen in the status. And now I can start typing. So you can see as I typed a bit and hit return and went down a line, so now I have 2 lines in the file, and the rest indicates it's still empty space. There are no lines there, and those characters are indicating that. So I'm in insert mode, and if I hit command or hit escape, I'll go back to command mode, and now I can run VI commands. And the first one you're going to want to know is how to get out of a file. So I just started the editor and didn't give it a file name to edit or a file name that I was going to be writing. So if I try to quit, and quit in VI is you hit the colon character to go down to the last line mode, and there are 2 different command entry types really in VI, or there's a couple different, but basically you can type commands in command mode by just hitting keys on the keyboard. So there's movement keys and search keys in that, and those jump you around in the text, move around easily. Or there's the other commands to the program that start with a colon, and that puts you in this mode down here where you can then enter a command. So you can hit colon and Q for quit, and it's going to warn me that I didn't write the file. I made changes and didn't write the file. So if I use W to write the file, it's going to refuse to do that because I didn't give VI a file name when I started it, and I didn't give it a file name to write. So in this situation, you would do :W for write, and then you give it the name of a file. We'll just call it dog.txt. So now it tells me that it's written the file, but W doesn't quit. W just writes the file. So there are a couple different ways to save and exit. The most common is 2 capital Z's, and for this one you don't need to type the colon to start the command. You just hit 2 capital Z's, and that exits the program. And you can see I've got the dog.txt file there. And I can cat that and look at it. So now if I would start Vim and give it the file name, now it's going to start the program with that file open because that's the file I told it I wanted to edit. So I'll quit back out of that. So I grabbed a copy of the example.txt file that we used in week 4 for the assignment. So I'm going to start Vim and edit that file. This file is much longer, so I have a lot of text here. Some quick handy movement stuff. If I hit Control G, Control and the G key, that's a quick status. So that tells me that example.txt has 78 lines, and my cursor is currently 1% of the way through the file. To quickly move through a file, you can do Control F to scroll forward, or Control B to scroll backwards, or you can do Control D to scroll down a half a screen full. So you can see, just watch this line here, just plain sudo. If I do Control D, it's just scrolled up a half of a screen's worth of text. If I do then Control B to scroll back a full screen, you can see that that is now off the screen because I went back a full screen instead of a half screen. So I'm going to go to line 0. So there are a couple of other different ways to move around the screen, some quick shortcuts. If I hit capital L, that's last, so that takes me down to, or last or lower, however you want to remember that. That takes you to the bottom of the screen. It doesn't take you to the end of the file, it just takes you to the last line that's actually showing on your screen. Or you can do capital H, which will move you to the upper left corner of your screen. And then moving around within the words and that, what you could think of as your arrow keys in VI are on the home row of your keyboard. So H, J, K, and L are movement keys. So and from left to right on the keyboard, they're left, down, up, and right. So H is left, J is down, K is up, L is right. So I'm going to hit a few L's. That takes me to the right. I'm going to hit some J's. That takes me down a line at a time. I can hit K to go back up a line at a time. Then I can hit H to go back to the left. And that's handy, but a pretty slow way to move around if you want to move around, more than a few characters at a time. So there's some other shortcuts. The W key will move you to the first letter of the following word from where your cursor is. The B key moves you to the first character of the previous word from where your cursor is. And then the E key moves you to the last character of the word following where your cursor is. So that's pretty handy ways to move around. And there are definitely more movement keys you can use and more examples of that in the reading. And then I want to show you, one other thing. One of the other really kind of cool things about VI is search and replace, and you can use regular expressions and all that. It can get really powerful. Basically, to search, you'd hit the slash character. So you hit slash, and you see that pops me to the bottom of the screen again. And then I can type in any text. I could type in a regular expression, all kinds of ways to search. I'll just type the word sudo, and that's going to find the first instance of the word sudo in the file. And then once you have a search going, you can see that at the bottom of the screen it still says /sudo to show me that it's got a search going. And then from there I can hit the N key to find the next instance of the word sudo, and I can keep hitting N, and it'll keep searching through the file until it gets down to the end of the file and finds one instance at a time of the word sudo. And you saw a quick flash there. I'll go backwards. And if you're in the middle of a file and you found a word and you want to search toward the top, you use capital N to search backwards. So you can see the little warning at the bottom. It tells me the search hit the top and it continues to the bottom. So searches, when you're using the N and capital N keys to move up and down through the searches, when it hits the end of the file in either direction, if you hit it again, it'll wrap around. So now you can see it says search hit bottom, continue at top. Another really fun thing about the searching is you can do a quick search and replace. And to do that, you use the colon to put it into command mode down there, to put it the last line command. Let's see. So I'm on the first line there. So if I do colon and then S for substitute and then a slash to start the indication of what I want to replace, and by default it'll start on the line that you're on. So say I want to replace the word sudo on the line there with mumu, let's just say, just for fun. So if I do that and I hit enter, you can see that it replaced the word sudo with the word mumu. And by default, when you do that, it'll only replace the first instance of the word that it finds on the line. If you wanted to replace every instance of the word on the line, you would run the same command, but after the last slash, you use G for global. In this case, global means global in the line. But you can do a full search and replace throughout the file as well. So I could do colon and then % to tell it to work on the entire file, and then run the same replace. So let's replace sudo with mumu, and I'm going to give it the -I option at the end to tell it that I wanted it to be case insensitive when it's searching and replacing. So it immediately jumps to the bottom of the file, and it tells me that it made 28 substitutions on 28 lines. So let's search backwards for mumu, and you can see that everywhere there was the word sudo is now replaced by mumu. And that was, you saw that was a very quick search and replace. You can also run that same command, and let's do it the other way. We'll replace mumu back to sudo, and I'll give it the C, and C is for check, so it'll find the first instance and ask if I want to replace. So it'll say replace with sudo, and I can say yes, and then I can say yes, or I can just say hit the A, and that is all. So then it behaves just as it did if I didn't give it the C option, and it replaces all instances in the file. And then I'm gonna quit, and so I've quit. I'm gonna quit here, but I've made changes. So if I try to quit now, it'll tell me that there's no write since the last change. And I can use the exclamation point or the bang to override, so I can do Q and then exclamation point, and it'll quit without making those changes. So if I run the vim example.txt again, you can see that none of the changes I made. If I search for mumu, it's not found. None of my changes were saved. So hopefully that was a good quick peek, quick demo of the VI Vim editor for you. Show you some of the just really the tip of the iceberg for the power of the editor. But it's it's as basic as you want it to be, and it's as powerful as you want it to be. As long as you get those few basic commands down, and remember the :Q for quitting and capital Z for save and quit, and how to get from insert mode to command mode and back. That'll get you started, and you can start editing with that, and then keep working with that and discover some of the really powerful features of it. So for this week, there's the reading, chapters 5, the shell, and chapter 6, the editors. Read the Vim section of that. Chapter 6, well, it's actually, I think I mistyped that a little bit. Chapter 6 is in the editors section. Chapter 6 is actually the chapter on the Vim editor. Read those two chapters. And then there is a quiz this week, and that is, as always, due at 12:01 a.m. on next Monday. Have fun, everybody. Definitely post questions in the discussion board if you have them, and I will talk to you next week.